Hello everyone, welcome to Brain Blitz Audios. Today in this episode of NEET preparation, we'll be looking at previous year questions of chemistry and medical entrance examinations in India. Today we're dealing with the chapter the D and F block elements. This is the 8th chapter in the grade 12 syllabus for chemistry in CBSE. So in this chapter we'll be looking at transition elements and D block elements, and also lanthanoids and actinoids, which constitute the F block elements. So we're going to be looking at reactions, and but more importantly we're looking at properties and lanthanoid contraction, etc. So without further ado, let's look at our first question. The first question is asking us to find out the product when you heat barium oxide with Philosophers Wool at 1100 degrees Celsius. So the key to this question is to find out whatever is Philosopher's Wool. So what do you think is known as Philosopher's Wool? Well, in ancient alchemy, on alchemical processes, you get ZnO as a white fluffy product, and that's why it's known as Philosopher's Wool. The name Philosopher's Wool is associated with zinc oxide. So it's basically zinc oxide plus barium oxide, and the temperature is 1100 degrees Celsius. And at this temperature, what happens is that there's a combination of both Ba, Zn, and oxygen. So you have barium and then zinc, which is acting amphoteric here, and then both the oxygens come together at the end, so BaZnO2 is our answer. So option C, BaZnO2 is the right answer, and the key here is to know that ZnO is also known as Philosopher's Wool. Now let's look at the next question. Which of the following is not an ore of iron? So here we have the word not, and it's the most important word here because it changes the meaning of the question entirely. So we need to find out which of these three, ores are not an ore of iron. So if none of them are, then option D will be the correct answer. But let's look at which of these are ores of iron. Option C, magnetite, is definitely an ore of iron because magnetite, also known as lodestone, was used to make early magnets and compasses. The ore consists of a deposit of Fe3O4, so option C cannot be correct. Now what about option A, limonite? Well, limonite is having the chemical formula FeO times OH dot NH2O. So irrespective of the number of H2O, limonite contains iron, and therefore it's an ore of iron, so option A is incorrect. So what about cassiterite? If you look at cassiterite contains the compound SNO. SN stands for tin, so therefore cassiterite is the main ore of tin. So therefore it's not an ore of iron. So option B is happening to become the correct answer. So since option B is not an ore of iron, then option D, none of these cannot be correct, so it is incorrect. So that's how you found out that cassiterite is the correct answer. We know magnetite. The only thing you need to learn is about limonite and cassiterite is also an often talked about example when it comes to ores. So this comes on chapter 6, which is talking about metallurgy. Now in this question you need to find out which of these four species is colorless. So what is the condition for becoming colorless? The condition is that the species must have unpaired electron in d orbital. So if it has unpaired electron in d orbital, then the species become colored. So if you look at option A, in option A, Cl has a valency of -1, So since there are 3 Cl, so the total is -3, and since VCl3 is a compound with charge 0, then the valency of vanadium in this case is +3. So V +3 is the ion, the species that we're looking for here. So for option A, vanadium trichloride, let's look at the electronic configuration of V3+. So in V3+, there is the loss of 3 electrons. So on writing the configuration, you get 3d2. So now the important thing to note is that vanadium has an atomic number of 23. 23 minus 3 gives you 20. So, and since the s electrons go first, so you have a configuration of Ar and 3d2 for V3+. So that means you have 2 unpaired electrons. And since there are 2 unpaired electrons, then this compound is colored. So option A is incorrect. What about option B? VSO4. It's actually VSO4, but because of a typing error, it became VOSO4. So option B, VSO4. So SO4 already has a -2 charge. So therefore, the charge for vanadium here is +2. Vanadium sulfate. So in VSO4, the charge on vanadium is +2. That means 2 electrons are removed. So that means you have 21 total electrons. Configuration of Ar gives you 18, and you have 3 electrons more, which you can write as 3d3. This again shows you that there are 3 unpaired electrons. So that means option B is also colored. So option B is the incorrect option. So what about option D? In option D, you have VH2O6, and then outside the square bracket you have SO4.H2O. So this is a coordination compound, and water acts as the ligand. The charge for water, since it's neutral, is 0. SO4 gives you 2-, so vanadium has to be 2+. So therefore, it's basically the same case all over again. So you have 3 unpaired electrons. So therefore, option D is colored. So if you look at it now, then since all the other options are incorrect, option C has to be correct. But let's look at a justification for option 3. So in option 3, you have Na3VO4. So oxygen has -2, so 4 times -2 gives you -8. Sodium is +1 times 3 gives you +3. And since the total charge has to be 0, vanadium must have +5 in its configuration. Vanadium must lose 5 electrons in order to gain a charge of +5, which will neutralize the compound. So for V +5, 23 minus 5 gives you 18. So you have 18 electrons, and that is exactly the configuration of argon, which is a noble gas. That means no unpaired electrons, which means that option C, in option C, the compound Na3VO4 is colorless. So therefore, the right answer is option C. Now, if you already have come across the question, then you would know that C is the answer just by looking at the configuration of V3+, V2+, V5+, etc. So this is the rigorous justification. It's dealing with the electronic configuration. For species with an unpaired electron present in their configuration in d orbital, the compound becomes colored. Otherwise, it's colorless. If it's paired, or if it doesn't have any unpaired electrons, then it's colorless. Let's look at the next question. Lanthanide, for which +2 and +3 oxidation states are common, is La, Pr, Ce, Eu. So La, which is lanthanum, is actually not a lanthanide. If you look at the rigorous definition of a lanthanoid is the set of 14 elements that come after lanthanum and whose electrons go to the f orbital. So therefore option A is not the right answer. And besides, lanthanum doesn't have +3 as common, so therefore option A is incorrect. Now option B is PR. PR stands for praseodymium. Praseodymium has the oxidation states +3, +4, and +5 as common, so therefore option B is incorrect. If you look at option C, cerium has the oxidation states +3 and +4, so therefore option C is incorrect. The right answer is option D, europium. Europium has +2 and +3 oxidation states as common. Now you know +4 and +5 may occur, but they are uncommon. For cerium, +4 is common, which is why it's incorrect, and for praseodymium, +4, +5 are incorrect. Are in common, but +2 is not common, so therefore options B and C are incorrect. Let's look at this question. Among the following pairs of ions, the lower oxidation state in aqueous solution is more stable than the other in. So you have option A, Ti plus, Ti3 plus, option B, Cu plus, Cu2 plus, option C, Cr2 plus, Cr3 plus, option D, V2 plus, and VO2 plus. So for this question, what we're going to do is we're going to take the configuration of each of these ions. So for Ti plus, the electronic configuration is argon 4s1 3d2. Basically, titanium has 22 as its atomic number, so therefore when one electron is removed, it was earlier 4s2 3d2, but now since one electron is removed from the s orbital, it becomes argon 4s1 3d2. And for titanium 3 plus, it will be argon. Both the electrons from s orbital and one electron from d orbital are removed, so 3d1. So among both of these, Ti3 plus is more unstable, so therefore option A is incorrect. If you look at option C, in option C it is Cr2 plus is the first ion. For chromium, the atomic number is 24, so Cr2 plus means that it has 22 electrons. Both the electrons are removed from the s orbital, so therefore you have 3d4 as the electronic configuration. For Cr3 plus, it will be Ar and then 3d3. So the electron with more, over here 3d4 is more unstable. So over here Ti3 plus is stable, Ti plus is unstable. But still option C is incorrect. If you look at option D, V2 plus and VO2 plus will not give you a stable oxidation state, so therefore option D is also incorrect. So that means option B is correct. But how do we prove it? So if you look at Cu plus, in Cu plus, you know that copper has atomic number 29, so that means copper has the unique way of representing 4s1 and 3d10. So if one electron is removed, then it will be just 3d10. And for Cu2 plus, it will be argon and 3d9. So therefore option B will be the correct option, because over here Cu plus is more stable than Cu2 plus when it comes to oxidation state. So option B is the correct option. This is the next question. You need to find out the color imparted by CO2 compounds to glass. So compounds containing CO2 plus will impart which color to glass. So whether it'll be option A green, option B deep blue, option C yellow, option D red. So let's look at each of the colors. For glass, green is due to the presence of chromium ion. So option A is incorrect. If you look at option D, which is red, it is also incorrect because red is present in glass due to selenium, manganese, cadmium, etc. And option C, yellow, is due to sulfur sulfur ions present in the glass, so therefore option C is also incorrect. That means the right answer is option B, deep blue. Deep blue is due to the presence of CO2+. That makes option B the correct option for this question. Now, this is the next question. Which of the following radioisotopes is used for anti-cancerous properties? So it is used as an anti-cancerous, say, treatment. So one of these isotopes is used as anti-cancerous treatment. You need to find out which one of these is the one. So in order to treat cancer, we usually use gamma rays in order to kill cancer cells. So that means one of these four options must produce gamma rays. If you look at normal radioactive isotopes, they emit beta radiation. So sodium-24 emits beta radiation. Carbon-14 also emits beta radiation. Uranium-235 also releases beta radiation. So that makes CO60 the correct option. Because in CO60 you have beta radiation plus gamma rays formed. So you have gamma rays forming in CO60. That's why it's used for anti-cancerous treatment. Now, the interesting thing is that beta radiation actually causes cancer. So therefore, if you are using sodium-24, carbon-14, or uranium-235, you would actually cause cancer in a person instead of curing it. And that's why CO60 is used, even though you have to be careful with it because it also emits beta radiation. Now, let's look at this question. Which of the following compounds is colored? So we need to find out which of these compounds is actually colored. Again, we use the principle of unpaired electrons in the configuration. So in TiCl3, titanium trichloride, you will have to remove the chlorine. So chlorine has a charge of -1, so it together makes -3, so titanium must have +3 as charge, or the oxidation state of titanium is +3. For +3 oxidation state, titanium has 19 electrons, so therefore the configuration of argon and 3d1 is the configuration of titanium 3+. This means that this compound must be colored. Well, that's good, but that doesn't mean that we should finish off the answer right here. Let's find out the rest of them. So next is ferric chloride. In ferric chloride, again, Fe has a charge of 3+. So for an element with atomic number 26, Fe3+ will give you 23 as the number of electrons, so that means you have 3d5 as the configuration of electrons. Again, this is an odd number of electrons in the d orbital, so that makes ferric chloride colored as well. The final option is, option C here is COCl2, so that means you have CO2+ as the cation. So in the cation, you will have argon and then 3d7 to be the combination, to be the configuration. So in 3D7, what happens is that you'll have 3 unpaired electrons, because we use the Hund's rule of maximum multiplicity here, and that's why you have 3 unpaired electrons if 3D7 configuration occurs. For 3D5, it's 5 unpaired electrons. For 3D1, it's 1 unpaired electron. So regardless of the number of unpaired electrons, it's still going to be colored. So if you can see that TiCl3, FeCl3, and CoCl2, all of these are colored compounds. Therefore, the right option must be option D, all of these. If you were to choose only one of these options, that would make the other 2 options as incorrect. So the most appropriate answer here is option D, all of these. And that's why it is the correct option. This is the final question of this episode. To obtain silver from silver amalgam, it is heated in a vessel which is made up of option A, copper, option B, iron, option C, nickel, option D, zinc. So this question looks simple, but it's actually quite tricky because this has a hidden clue. So over here, the question is to obtain silver from silver amalgam. It should be heated in a vessel made up of. So you need to get silver from AgHg. So mercury can form more than 1 amalgam, so therefore the vessel, the metal of the vessel, must not form an amalgam in order for pure silver to be obtained. If you look at option D, zinc can form an amalgam that is ZnHg, so option D is incorrect. Nickel also forms amalgam, so option C is incorrect. Option A, Cu, is also incorrect because copper can also form copper amalgam. The only option that's right here is option B, iron, because iron generally does not form an amalgam with mercury. So when there is no amalgam formed, then you can safely obtain silver from silver amalgam. So you get pure silver whenever the vessel is made up of iron. And that's why option B is the correct option. That concludes this episode of NEET preparation. We hope you found this episode interesting. For watching more of our videos on NEET preparation, you can always click the link in the description down below. For getting more of our useful and interesting content, don't forget to subscribe to our channel, which is Brain Blitz Audios. Until the next episode, take care, stay safe, bye-bye for now.